Welcome everyone to another interview of our training program. Today we are joined by Professor Albert Beckers, the president of our association, ENEA. Professor Beckers is Emeritus full professor at the University of Liège in Belgium. And for more than 15 years, he was also head of the Service of Endocrinology at the University Hospital Center of Liège. Therefore, it is a pleasure interviewing Professor Beckers today for our training program. First of all, thanks so much for agreeing to chat with us. And I am sure that your words will be super valuable for the young members of our society. So let me start our interview by asking you why and how did you decide to start studying pituitary gigantism?
Actually, it's a very long story. It started in the years 80s when I started my specialization in internal medicine and endocrinology. I was already interested by neuroendocrinology, and I was studying pituitary adenomas in general. I was concentrated on immunohistochemistry, immunocytochemistry, and pulsatility of hormones and rhythmicity in general. But in the year 90s, then I evolved from pituitary adenomas in general and acromegaly, that has always been my favorite, to familial disease, to genetics in pituitary adenomas. And during the first years of the 90s, I developed a study on association of pituitary adenomas and MEN1, and we studied that for several years. But in the same time, I had several families with familial acromegaly that was not linked to MEN1 or to Carnet complex. And we published one paper with familial acromegaly. But in the same time, I observed that it was not only an association of several acromegaly patients in the same family, but there were different kinds of associations. There were prolactinomas, Cushing's disease, acromegaly, etc. And so it was not appropriate to continue to speak about familial acromegaly. So I introduced the acronym FIPA for familial isolated pituitary adenomas. And so we studied FIPA, and it took several years to publish a big paper in GCNM in 2006. Because we had to accumulate several FIPA families to convince people about the existence of FIPA. And in the same years, in 2006, there was a beautiful publications coming from Finland, from the group of Lauri Altunen, who published the association of mutation in AIP genes and some case of familial pituitary disease. So we immediately studied our FIPA patients, the full series of FIPA patients, so more than 150 cases. And 1 year later, we were able to say that more or less 15% of the FIPA families have AIP mutation. And we already observed that they were younger than FIPA AIP negative, and they had bigger tumors. So we wanted to be sure about that. So we launched another international study, and in 2010, we published a publication where we compared 75 acromegalic with AIP mutation and 202 acromegalics without the mutation. And we showed that they were much younger, less than 20-year-old at diagnosis. They had bigger tumor, it was true, more aggressive tumor, more difficult to treat. But also, as a consequence of the fact that the tumor occurred early in the life, before the epiphyseal closure, you have lots of giants in this area. So we had 1/3 of these patients with AIP mutations who were giant. And so it was a dream for a long time for me to study gigantism. I always have been fascinated by gigantism, but there was no study. And I know why. It was because gigantism is so rare that it's difficult to accumulate a series of giants. But then we had a unique opportunity because we had already a big number of giants. So we launched a study on gigantism. And we published this big series with Dr. Rostomian, first author, in 2015. And we learned about the genetic of giants. We learned that actually 1/3 of the giants have an EIP mutation. And in 10%, we had a surprise because I was assisting to an official ceremony with your former boss, Dr. Stratakis from the ENEA. And he told me that in the 10 patients that he sent me for the series of 200 giants, there were several abnormalities that he could not explain. And among these abnormalities, there was a duplication of several genes, 11 genes, on chromosome X, that he found 2 years before, but he could not reproduce that. And he had, of course, no idea at the time if it was important or no. And so we decided to collaborate, and you were included in this collaboration together with Adrian Daly and from my group. And actually, the answer to this difficult problem came from traveling after FIPA publication. So after the FIPA publication, I was with pleasure invited in many countries speaking about FIPA. And I never avoid to speak about the fact that patients with AIP mutations were young in general and had big aggressive tumor. And so always after my conferences, there was a pediatrician or an adult, an endocrinologist for adults coming to me and telling, I have this young patient with a big tumor and aggressive tumor, difficult to treat. Do you think we should search for AIP mutations? And of course, the answer was always yes. And in more or less 20% of the cases, we found an EIP mutation, and we studied the family. And in 80% of the cases, we stored the DNA in the fridge. And so coming back with this conversation with Konstantin Stratakis, we went back to the fridge. And what was interesting is that after 1 or 2 weeks, we had already the certitude that we had a new disease, because the first case that we studied had also the duplication, and then a second, and then a third. And within 6 weeks, we had the diagnosis, and you remember that very well because you were informed about all the progress on this study. And you did a lot of things in your laboratory with Constantine. And so this discovery is really due to fortunate, a good interference between 2 people, one observing something bizarre, and the other one having the DNA to study, enough DNA to confirm the case. So we had a new disease that we all decided to call this new disease XLAC, and that is due to a duplication of GPR101 gene. So this was unexpected. I would say this was exceptional, and it was for somebody who wanted to study gigantism, it was a good award, a good discovery. We could not expect to make a so beautiful discovery, I would say. And then what is important and interesting, I think, is that when I was a young endocrinologist, there was always a conflict between surgeon and endocrinologist, thinking about the origin of the pituitary adenomas. And some of them saying, it's a pituitary origin because when I remove the pituitary adenoma, it disappears and it doesn't come back, at least not always. And the endocrinologist said, oh, yes, but there are great connections between the hypothalamus and the pituitary, so it might be that the origin is in the hypothalamus. And in this case of XLAC that you studied with us, it's very interesting, the physiology, because you have not truly at the beginning a pituitary adenoma, but you have a hyperplasia. If you measure GHRH, you have high level of GHRH. And if you study by immunohistochemistry GHRH receptor in the tumor, there is a high concentration of GHRH receptor in the tumor. And so we believe from the beginning that this disease is not only a pituitary disease, that it might be also a hypothalamic disease, or might be a hypothalamic disease only, but with pituitary consequences. Actually, we know today that it's a hypothalamic pituitary disease because we developed with pharmacists in Liège, we developed a model with hyperexpression of GPR101 at the pituitary level in mice. And in these mice, we have hyperexpression of GPR101, but there is no hyperplasia, not at all. Whereas in the human, we have the hyperplasia, and we have high GHRH level that is not present in the mice, which is normal because the gene is overexpressed only at the pituitary level. So the most probable is that in the human, you have a model with two turbo, one turbo on each somatotroph cell that allows her to secrete more GH than the normal, and another turbo at the hypothalamus level that allows the neurons to secrete more GHRH. And this GHRH is probably producing the hyperplasia that we observe in at the pituitary level. So there is a double mechanism that finally is able to produce the tallest giant in the world, the tallest, the most important gigantism that you can find in humans, with people measuring 2.72 meters, the tallest ever. And the tallest that we had the opportunity to study was 2.59 meters. So I think that it was, yes, a very important discovery, and that has consequences in the treatment of patients. Maybe this is a very rare disease, so on this point of view, it's not important. It's not so important, but these people are ill and need to be treated and to be treated on time. But on this point of view, the most important is to have medical treatment and operation. So the discovery of the gene maybe is not immediately having consequences on the treatment of patient. But the most important is on the physiological point of view. We now know another pathway for growth and for growth hormone, and another mechanism that is probably situated at the hypothalamus and pituitary level. So this was, yes, a research that we did with great pleasure, and we had the pleasure to share that with Adrian Levy, you and your former boss. And it was a great collaboration with, I think, great results.
Thank you. Of course, I am biased because I was involved in this story, but I find it super interesting, and I'm sure that also it has a great lesson for our in-training members of our society. So let me also ask you, what did you enjoy the most about this long research journey?
Well, the thing is that when you are a scientist who loves to do discoveries, if you are curious, and every day morning you go to the lab or to the department thinking to what will I see, what will I discover new today? It's not always big discovery, but it's sometimes lots of little discoveries that finally have a conclusion on not so little discovery. Or sometimes it's just a little discovery, but just having the pleasure to discover a mechanism or a new disease or something like that, it gives great pleasure. As a doctor, because I never stopped seeing patients, so I always saw patients for every week, and particularly patients with pituitary disease. So as a doctor, when you have the opportunity, because it's not only gigantism, we did lots of work on epidemiology and treatment and lots of things. When you have the opportunity to better treat your patients and to better diagnose your patients, as a physician, it's a great satisfaction, of course, because you can share this satisfaction with your patients, and It was both are linked. So when you are a physician, you like to treat your patients, you like to discover things, and you like to come back with the patients and with the new treatment or new diagnosis or new what you like, but something important and new for the patient that allows better treatment and diagnosis.
Yeah, this is all very, very true. I can relate to the research. I'm a biologist, so to the research part, I can subscribe to that, to the little joy that you can find every day at little, even for a little discovery. On the other hand, what did you find challenging during this project?
What was challenging? Yes, for example, when we had this first discussion with your boss, and we decided to collaborate, and soon after we had, as I said, after 1 week, we had one new case with the same locus, so we were sure about that. So after 1 week, we were sure that we had in the hand a big discovery. And then from that moment to the publication in the New England, the way is long because you have one case is not enough. So you have to study the other cases, and then you have another one, and then another one, and then another one. So it's more and more challenging and exciting. And you have to coordinate all the work because you have to. There was part of the work that was done in Liège. There was part of the work that was done in your lab. There was part of the work that was done in other lab, in Marseille lab, for example. We did a part of the study in Marseille. And we were continuing to collect DNA, so we still have to convince investigators. I remember an investigator who had a young patient with definitively the diagnosis of X-lag. I was sure about the description of the patient, but there was some hesitation to give me the DNA. So I had to convince him that he would be happy to have the response to his problem, because it was a problem for this young patient that was growing and growing with no good knowledge about the disease, so no good appropriate treatment. So on this point of view, I think that even we did not change completely the way of treating the patients. Just the fact of we accumulated, maybe the series is now 40 patients in the world, or a little bit more today, but not much more. Having all this, or more or less all these patients with an experience, with a treatment, with an evolution, allows to treat them better than before. And so it's a lot of coordination. You have to make all the hypotheses. You have to have all the appropriate collaboration in the world for the DNA, but also for the technology, the things that you have to do with the DNA to demonstrate things. And so this is the challenge. This is the challenge because it's not human, and you have to convince people and thereafter to organize the coordination in the good order and to accumulate the results and to treat well the results. It needs applications, I would say. It needs work, and I have to confess, it's the period of time in the war in my life I have worked the maximum probably, and I am sure it's the same for you. I remember working with Adrian Daly during the meeting. I don't remember where, but we were working in the room of the hotel, trying to find new case and then to progress in the physiology of the disease, of the mechanism, etc. So it's a period of time where we were so enthusiastic all together that I think we were thinking 24 hours on the disease and the physiology of the disease. I don't know if I can speak at your name also, but
no. It's true. It was for me. It was it was a very busy period, tiring, it's rewarding, interesting. Every day was very. I mean, was very, very, very involved in the lab, but with joy, because at the end it was a very nice new thing that we discovered. So yes, I agree. So finally, let me ask you if you have one or more advice that you would like to give to the young members of ENEA that are watching us.
Well, maybe follow your curiosity. Make observations. So observe what you see. Try to understand what you see. If what you see is not what is published, believe first what you see, and then try to demonstrate that it's true. And if it is not true, you will understand. But if it is true, it's a discovery. So it's interesting. So don't believe immediately in the guidelines. So if what you observe is very much different from what everybody accepts in the world, then try to explore that properly and to demonstrate it. I think it's the most important thing, because if each time you see something bizarre, you say, it's not in the textbook, it's not in the guidelines, so I do not consider. So it must be like in the textbook like that, then you will do no discovery. So what is interesting is what is bizarre.
Yeah, okay.
And if you have something like that to explore, do it with energy, and don't hesitate to collaborate with other people, because I think that this discovery it's a good, beautiful illustration of how a good collaboration is important to succeed, because it's not the time like in the 19th century where you had the scientist alone with his microscope working. This is more or less finished. All this has been done a long time ago. Now with the new technologies, you need collaborations in general. In general, you need collaboration.
Yeah, I agree also with that. So thank you. Thanks so much again to our ENEA president for telling us about his amazing research studies, and for all the precious lessons that were directed to the next generations of scientists and also clinicians. So to our next interview. Bye-bye.
Bye-bye. Thank you.